Free Throws, Are They Really Free? By Matt Lucian, Ben Kohlberg, and Ryan Davies. How do velocity and release angle affect the accuracy of a free throw? So before we start, here's some basic information about free throws and the NBA. The average NBA height is 6 feet 7 inches, and the average NBA release height on a shot is 7 feet 3 inches. The distance from the hoop to the free throw line is exactly 15 feet, and the height of the hoop off the ground is a well-known 10 feet. The width of a hoop is an 18-inch diameter, which would make the radius 9 inches. And then using the circumference equation, we found there was a 56.5-inch circumference of the rim. So we will be using projectile motion to determine the success or the necessary angle and velocity of a free throw for it to go in. Projectile motion is the vertical and horizontal components of motion. So the motion of the ball in this case is affected by both vertical and horizontal components. Both of those will also be affected by the velocity and the angle. So figuring out the optimal angle and velocity will determine what the necessary horizontal and vertical components will be for the shot to go in. Release height is another possible factor that would influence the travel time of a free throw. It has been determined to an extent that a higher release of the ball is slightly more successful, but this is not completely conclusive. So the projectile motion equations we'll be using for horizontal, x equals velocity times time times cos of the angle, which is the release angle. And for vertical, it's 1/2 gravity times time squared plus velocity initial times the sine of the angle times time plus the release height. So that's where the release height will factor into this equation. For this equation, though, we will keep the release height constant at 7 feet 3 inches. So now we will actually plug into the equations. So for velocities, we will use between 23 and 27.5 feet per second because the average NBA velocity on a free throw is 25.5 feet per second, and we'll just increase by increments of 0.5 feet a second. And we'll use angles between 49 and 58 degrees since the average is around 54 degrees in the NBA. So the results of our experiment, we took 10 shots with different velocities and angles. 4 of these 10 shots were hit with the given statistics: 50 degrees and 23.5 feet per second, 51 degrees and 24 feet per second, 52 degrees and 24.5 feet per second, and 53 degrees and 25 feet per second. Now, 6 of these shots missed, but 5 of them would have gone over the necessary distance that the ball needed to travel and might have hit the backboard. So those could have gone in, but for this experiment, we're doing simply swished shots only, so no backboard. So our findings were that the optimal angle was a 51.5 degree angle release, and the velocity would be around 24.25 feet per second. Now, it's worth keeping in mind, though, as we said, that some of these shots might hit the backboard and go in or hit the rim and go in. This is just an optimal swished free throw, and also other angles and velocity combinations within the parameters we outlined before may work as well.
As an extension of our project, we decided to run a statistical analysis, and the statistical analysis test we chose was a linear regression test. And basically what a linear regression test is that it can be used to determine the certainty regarding a correlation between variables. And so in our project, we measured whether or not field goal percentage and free throw percentage were correlated. For example, if a player is a good free throw shooter, are they also a good do they also have a good field goal percentage? And in other words, does a higher field goal percentage result in a higher free throw percentage, and vice versa? And so we used 10 of the NBA's most efficient players, and their EFF rating is basically a compiled stat that pulls together what a player averages in terms of points, steals, blocks, field goal percentage, turnovers, and shots per game. And so we did this because players with higher EFF ratings are typically the best all-around players in the league. And so we wanted to use the stat to determine the correlation between field goal and free throw percentage based off of the league's best players, because we thought that those players would represent the league and the NBA and basketball in general the best. And we also chose players from varying positions such as centers, small forwards, shooting guards, and point guards. So we chose 7 players with high EFF ratings and correspondingly high field goal percentages, and 3 players with high EFF ratings and low field goal percentages. And we did this to see if the best players with the high field goal percentages had a correspondingly high free throw percentage, and in contrast, to see if the best players with low field goal percentages had correspondingly low free throw percentages. So here's a table of the 10 players we measured, as mentioned before. And the blue names are the 7 players with the high field goal percentages and the high EFF ratings. And the red names are the players with high EFF ratings and low field goal percentages. And so, as you may already be able to tell, the blue names generally have a higher corresponding free throw percentage, and the blue names generally have a lower corresponding free throw percentage. So with the data table on the last slide, we created a linear regression scatter plot graph to represent the data. And so on the x-axis is the field goal percentage, and on the y-axis is free throw percentage, and the points in the graph are each of the players. And we created a trend line using Microsoft Excel. And the equation for the trend line is shown along with the r-squared value. We'll explain what the r-squared value means later on. But as you can tell by the trend line, as field goal percentage increases, there's a corresponding increase in free throw percentage. So after running a summary output analysis on the data using Microsoft Excel, these results were found. And so within the results, there's a lot of extraneous and unnecessary data. However, the main things to look at are the values that are colored in. So the main stat to pay attention to, which we highlighted in red, is the r-squared value. And so r-squared is a statistical measure of how close the data is to the fitted regression line or the trend line. And thus, because the r-squared value is 0.7558, approximately 75% of the variation between field goal percentage and free throw percentage can be explained by the regression of distance on speed. And another important stat, which is highlighted in blue, is the SS value. And this stat, because it's greater than the p-value, which is also highlighted in blue, shows that our sample data is sufficient evidence to conclude that our regression model fits the data better than a model with no independent variable. In other words, the independent variable in our model improves our calculations. Finally, another important stat is the significance F value, which is also highlighted in blue. And this stat shows the percentage that a variance in our data when no variance actually exists. In other words, if there's approximately, according to our data, there's approximately 0.001% chance that the data in our tests appear skewed when they're not actually skewed. And so, as a general sense, the lower the significance F value, the more precise the data. So because our significance F value is so low, our data is pretty precise. And so with this data, we can pretty reasonably conclude that field goal percentage and free throw percentage are correlated, and they are related in a pretty proportional way, because as field goal percentage increases, free throw percentage correspondingly increases.
Other influential factors. Does the level of crowd noise influence a player's ability to make free throws? So the loudest NBA arena this past season was Oracle Arena in Oakland, California. The average NBA free throw percentage was 75%. And at Oracle Arena, the average free throw percentage was 74.1%. The statistic is immeasurable because every player deals with pressure or sound differently, and it's a matter of psychology and not more quantitative. And also certain arenas claim to be better for shooters, such as the Cavaliers Arena. Do taller players make more free throws than shorter players? Shorter players tend to be more accurate from the free throw line than taller players. An example we have is Steph Curry is 6'3", and his free throw percentage is about 92%, while LeBron James is about 6'8", and his free throw percentage is about 73%. Do players with more free throw attempts in their careers shoot better? So some players end up on the line significantly more than others. We took 4 significant NBA players: James Harden, LeBron James, Stephen Curry, and Dwayne Wade. And as you can see, James Harden had the most free throws per game LeBron James came in second, and so on. But the free throw percentage doesn't exactly correlate with how many free throws they take, as LeBron James had a significant amount of free throws per game, but not a very high free throw percentage.
Our conclusions for our overall experiment. The most accurate angle and velocity combination we found was a 51.5 degree angle and a 24.25 feet per second velocity. Now, this is the most safe and efficient combination. Of course, other combinations of angles and velocities within certain parameters will work. So angles between 50 and 50 degrees will work, given a good velocity, and the other way around, velocities between 23.5 and 25 feet per second will also go in if the angle functions. And shots that go over might hit the backboard and go in, as we've mentioned. So our test was semi-perfect because we did not acknowledge the backboard, but there's many more factors that would go into finding out whether the shot would go in off of the backboard using angles and velocities. So swishing a free throw, these are the safest results we could get: a 51.5 degree angle and 24.25 feet per second shot.
So an aspect of our conclusion, which is the statistical analysis linear regression test, allows us to reasonably infer that there's a correlation between field goal percentage and free throw percentage. And we found that the variables are generally proportional, in that a higher field goal percentage usually results in a higher free throw percentage. And we did this test based off of 10 of the league's best players, because we thought that because the NBAs were usually the most elite basketball players in the world play, this would be a good representation of basketball as a whole. And the connection between free throw percentage and field goal percentage is an example of how some variables that may seem independent from one another, in this case, field goal percentage and free throw percentage, actually have an effect on how successful a player shoots the basketball from the free throw line. And so this experiment can kind of open doors to help people figure out how some factors may surprisingly affect a player's free throw percentage, some unexplained factors that may seem to have nothing to do with free throw percentage, but they actually may be able to determine whether or not a player is a better free throw shooter or a worse free throw shooter.
Do other factors influence the free throw shooting of players in game? Our research suggests that taking free throws in different arenas does not affect a player's free throw abilities. However, the stats are practically immeasurable, as the crowd noise affects player mentally, and therefore it is difficult to state how much the crowd noise levels affect the player. Many NBA analysts and NBA fanatics will claim certain arenas have more of an effect on players' ability to perform well, but for our purposes, the statistics are immeasurable. It seems that there is a trend that is almost universal around the NBA. It is usually the height of the players are inversely correlated with the player's ability to shoot the ball. Besides a few exceptions, it seems that shorter players seem to have higher abilities of shooting the ball. Therefore, as height increases, the player's free throw percentage should decrease. And after comparing the amount of free throw attempts with free throw percentage, we concluded that these two variables do not relate to each other, as LeBron James, a player with one of the highest free throw attempts per game, has a fairly low free throw percentage, showing us that a player with more experience at the free throw line may not necessarily be a better free throw shooter.